All right, so hopefully the lesson here will be pretty quick. It's not a huge thing to learn, but we're actually going to go back to limits here. And you might be saying, why are we going back to limits? We did limits in September. It's now, almost November. Why are we doing limits now? And that will become evident in a couple minutes. But let's take a look at this limit here, the limit as x approaches 1 of ln of x over x minus 1. So again, I kind of outlined here, the first thing, if you remember, that we would try to do is plug in 1 for x. All right, we'd plug in 1 for the x in the ln and 1 for the x in the denominator. But the problem is when we do this, we get 0 over 0. Now you remember when we had a situation like this, what we tried to do is that we might try to factor, right? Factor and cancel out terms, but there's really nothing to factor here. You can't factor ln of x. Obviously, you can't factor x minus 1. So you might be saying, all right, well, maybe I could try the quotient rule. I imagine most of you are saying, I have no idea what the quotient rule for limits is. Well, if you remember, it was if we take the limit as x approaches 1 of ln of x over x minus 1, it was the same thing we discovered, if you remember, as breaking it down into the limits of both the numerator and the denominator. So I could find the limit as x approaches 1 of ln of x individually and divide it by the limit as x approaches 1 of x minus 1. But as you can see, it doesn't really help us. We still get 0 in the numerator and 0 in the denominator. That does not mean, if you remember, that there is no limit or 0. Certainly 0 over 0 is not 0. But there's got to be this guy named Marquis de l'Hôpital. It's sometimes spelled with the S, sometimes it's left out, right? So if you look down at this guy's name here, it's kind of a fun name to say. That S there, sometimes it's left out, sometimes it's left in. But this man named Marquis de l'Hôpital ran into the same problem. He got these equations or limits that gave him 0 over 0 and said there must be a way that we can actually solve this. And he came up with a way to solve limit problems where we get two scenarios. One like we just saw. So he said, I'm going to develop a way to actually find the limit when I get 0 over 0, or if I get something like infinity over infinity. So what you need to know here is that if you get 0 over 0, or you get infinity over infinity, we can use this rule that L'Hopital came up with back in the 1600s. And you might be curious as to what that rule is. Okay, and what he discovered, that was the limit as x approaches a of f of x over g of x, if we get 0 over 0 or infinity over infinity, was the same thing as if you did the limit as x approaches a of, of f prime of x over g prime of x. This is sort of like what you were hoping probably the quotient rule was when we first introduced the quotient rule. Just take the derivative of the top over the derivative of the bottom. That's what we get to do here with L'Hopital's, which is very nice. Notice we're not doing the limit as x approaches a of some quotient rule of f over g. We are literally just taking the derivative of the numerator and dividing it by the derivative of the denominator, and then we're going to try to replug in the value. If your name is Whitney, you're probably wondering what the proof of that looks like. I'm going to spare you the pain of that. If you're really curious, you can go to YouTube, just Google proof of L'Hopital's, and after the first minute, I think you will give up. But if you're interested, it is out there, but I don't want to go through it now. So, can we apply L'Hopital's rule to the problem above? So let's see how that might work. So we do have this limit, right? We have this limit as x approaches 1 of ln of x over x minus 1. And again, if you got this problem for the first time, the first thing you'd still try to do is plug in 1, but we get 0 over 0. So here's what we're going to do. We're going to apply L'Hopital's rule, and remember that the limit of ln of x over x minus 1 is the same thing as the limit as x approaches 1 of the limit of the numerator, which is, or not the limit, the derivative of the numerator, which is 1 over x, over the derivative of the denominator, which is 1. So I just took the derivative of ln of x, and I took the derivative of x minus 1. Now, what I'm going to do is try to plug in the value of 1 again. So I get 1 over 1 all over 1. So you get 1 over 1 over 1, we get 1. And that is our limit. Okay? Again, it may seem like, why would you do that? Again, if you really want to check out the proof of it, by all means, go for it. If you just want to take my word for it, then that's all we need to do. So it's a pretty simple rule. Just remember, you only can use it when you get infinity over infinity or 0 over 0. All right, so if you go to the back page, okay, there are 3 problems here. The limit as x approaches infinity of e to the x over x squared, the limit as x approaches infinity of ln of x over root x, and the limit as x approaches pi from the negative of sine of x over 1 minus cosine of x. I would highly suggest, if you feel confident in the L'Hopital's rule, to pause the video and try all 3 problems. And once you've done all 3, or at least as far as you can go, hit play and watch me for the solutions. If you don't quite feel comfortable yet and you want to watch me do the first one, watch me do the first one, then hit pause and try to do the remaining 2, okay? But try to do a few on your own if you can by hitting pause. Again, once you hit play, I will run through all the solutions here, okay? So you can certainly check your work. All right, so hopefully you tried a few, or if you want to run through this first one with me, that's fine too. So we have the limit as x approaches infinity of e to the x over x squared. If I try plugging in infinity in for both, e to the infinity is really just infinity. X squared, infinity squared, is going to be infinity. So I get infinity over infinity, which means I get to use L'Hopital's. Okay. I'm leaving the S out of this. Sorry for the handwriting. It's a little hard writing on the iPad. So when we use L'Hopital's, again, we can remember that the limit in this case as x approaches infinity of e to the x over x squared is going to be the same thing as the derivative of the numerator and the denominator as e to the x over 2x. But you might find now, and you might be able to do this in your head, if I plug infinity in for x in the numerator and the denominator, I still get infinity, right? I'll only choose a different color. Let's go blue. This one would still give me infinity over infinity. Okay, I still have a problem. So guess what I can do? I can actually take the derivative again of the top and the bottom. So what I'm going to do is take the derivative of e to the x again, and I still get e to the x, and the derivative of the denominator, which is just 2. And I'm going to try replugging in again. And when I do that, I get infinity in the denominator, but I get 2, or excuse me, I get infinity in the numerator, but I get 2 in the denominator, which means the overall limit, if I have infinity over 2, is just going to be infinity. Exclamation point. So the limit as x approaches infinity of e to the x over x squared is just going to be infinity. All right, so let's take a look at the next one. If hopefully you've tried it. If you have not, I would encourage you to hit pause and try this one on your own. But the limit as x approaches infinity of ln of x over root x. Okay, I'm just going to actually rewrite this so it's a little bit easier for me to take the derivative if I need to. Well, actually, before I do that, let me just make sure it's infinity over infinity. Ln of infinity over the square root of infinity is infinity over infinity. So I will need to take L'Hopital's rule. Before I take L'Hopital's, let me just put this in a form that I'm comfortable taking the derivative of ln of x over x to the 1/2. Again, we're going to take the derivative of the numerator and the denominator separately. The derivative of the numerator is 1 over x. The derivative of the denominator is 1/2 x to the negative 1/2. Okay, which is, if I try to do a little simplification, 1 over x over 1 over 2 root x. If I do some same change flip action, I get 1 over x times 2 root x over 1, which is the same thing. If I subtract my exponents from each other, I have a 1/2 in the numerator and a 1 in the bottom-nator. I get 2 over root x. So that whole thing simplifies to 2 over root x. It's really kind of slanted here. Don't know why. And now if I try replugging in infinity, I basically have a bottom-heavy function, right? At this point. So my overall limit is going to be 0. Exclamation point. Again, all I did was just take the derivative of the numerator and the denominator when I get an infinity over 0 over 0, until I get a limit that I can handle. Okay, until I get a limit that I can handle. All right, so if we look at the last one, the limit as x approaches pi to the negative, or from the left, of sine of x over 1 minus cosine of x. If you immediately jumped into L'Hopital's, shame on you. Don't forget our limit rules. The first thing we're always going to try to do is plug in the value. If I plug in pi for sine, sine of pi is 0. If I plug in pi for cosine of x, cosine of pi is negative 1. So I get 1 minus negative 1, or 0 over 2. That means my limit is just 0. We cannot use L'Hopital's rule if I can plug in a value and get an answer from the beginning. You can only use L'Hopital's, okay, when you get 0 over 0, or infinity over infinity, okay, or negative infinity over negative infinity. That's the same thing, okay? If you use L'Hopital's preemptively, like you used L'Hopital's in this sine of x over 1 minus cosine of x, you will get the wrong answer. So still, always stick to our limit rules by plugging in the value. If that doesn't work, factor and canceling out. If that doesn't work, if you're getting 0 over 0 or infinity over infinity, you go to L'Hopital's. If you're getting a number over 0, okay, if you're getting, when you plug something in, you get, 10 over 0, okay, you cannot use L'Hopital's. It has to be, okay, 0 over 0 or infinity over infinity. If you get something like 10 over 0, you're going to have to use those methods we've talked about before, where maybe you go to the graph, or maybe you feel plugging numbers really close to the value is going to work for you, but you cannot use L'Hopital's. Only when it's 0 over 0 or infinity over infinity, okay? That's it. That's all L'Hopital's is. It's a pretty simple concept to grasp and actually to use, but the tricky part, not even the tricky part, the thing you just need to remember is that you can only use it in certain situations. All right, so there's homework from the book. It's not too bad. It's really just some practice on some L'Hopital's. This video, as I'm looking at it, is 12 minutes and 20 seconds right now. You have plenty of time to complete the homework well before the period ends. Okay, if you're doing it during C block, and then there would be no homework for you. Okay, I'll take questions when I see you guys tomorrow.